Good morning, everybody. I want to talk to you about our next math lesson, which is Fractions of a Group, lesson 8.7. We're going to be talking about how you name a fraction of a group. Okay, we want to name part of a group, and we're going to give it a fraction name. So let's take a look here at Jake and Emma's marbles. Jake and Emma each have a collection of marbles. What fraction of each collection is blue? So we can use a fraction to name part of the group. Take a look at Jake's marbles. How many marbles does Jake have altogether? Well, if you count them, I see 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So 8 is my denominator. How many blue marbles are there? Talk to somebody next to you or around you. I'm going to count them. I see 1, 2, 3. So I'm going to make my numerator here 3. So Jake has 3/8 of his marbles that are blue. Now let's take a look at Emma's marbles. This is a little different. We're not counting individual marbles. We're counting bags of marbles. Okay? How many bags do I have? I got 1 bag, 2 bags, 3 bags, 4 bags. So my denominator here becomes 4 because the total number of bags is, you got it, 4. Now, I want to find out how many bags have blue marbles. Well, this one's got red, got a blue, a green, and a yellow. So 1 bag here is my numerator. 1 bag is blue. So the numerator becomes 1. So 1/4 of Emma's marbles are blue. Now, it's important to realize if you start counting individual marbles, you have to count individual marbles the whole way through. If you start counting bags of marbles, you count bags of marbles all the way through. Okay? So let's take a look here. This is drawing, so I'm going to skip over that one because we can't really draw on the computer, at least not the way I have it set up. All right. So here, let's talk about fractions greater than 1. We talked about fractions greater than 1 yesterday, but not in a group, just for one fraction. But now let's look at Daniel and his baseball collections. Okay, sometimes a fraction can name more than a whole group. So Daniel collects baseballs. He has collected 8 so far. So he has 8. But he gets cases that only hold 4 baseballs each. We want to know what part of the baseball cases has Daniel filled. So here's a clue in blue. 1 case equals 1. That would be 1 hole. So this case right here, that's 1 hole. So I can look at this right now and say he's got 1 case filled, 2 cases filled. So he has 2 holes. But now let's find a fraction greater than 1 to name those 2 holes. So always, first thing to think of is find your denominator. Well, I'm just looking at one of those at once. So if I were in school right now, guys, I would cover up that bottom case so you could just see the 1. And I'd figure out how many pieces it's broken into. I see 4 baseballs. So that to me means that we are working with fourths because there's 4 in each one. Okay? So now I simply count the baseballs and I call them fourths. And I'm going to have a numerator bigger than my denominator because it's a fraction greater than 1. So go ahead and count the baseballs. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. So it's important to remember here that I'm not saying baseballs are fourths. I'm saying we're talking about the fractional part of this whole. And the whole includes those 2 cases. Okay? So 8/4 is a fraction greater than 1 to name that picture with 4 baseballs in each case. Okay? So let's look at these. These questions are a lot like those baseball ones. Okay, we want the whole number and a fraction greater than 1. So again, if I were in class for letter A, we've got 3 muffin tins or cupcakes. Cover up 2 out of the 3. So when you're watching this, literally use your hand on the screen. That's what I'm doing right now at home. Cover up 2 of them, and let's figure out our denominator. Okay, so I'm just looking at 1 muffin tin. I see that I have 1, 2, 3, 4, 5, 6 muffins in 1 hole. So my denominator is going to be 6. And down here we've got these clues. 1 pan equals 1. We just talked about that. And here's your denominator, 6. Okay, so these are now sixths. So let's count how many sixths we have. Well, I know I've got 6 in this first pan. 7, 8, 9, 10, 11, 12. Oh, wait, that's like 6 times 2, 12. Can I do 6 times 3? Or I can just count on 13, 14, 15, 16, 17, 18. Or I know that 6 times 3 is 18. Okay? So this is going to become 18 sixths. Okay? I could read this 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11, 6, 12, 6, 13, 6, 14, 6, 15, 6, 16, 6, 17, 6, 18 sixths. That took a lot longer, didn't it? That's why I wanted to just jump to adding sixes, but if you want to count them out one by one, I want you to do what works for you. Okay? So we got the fraction greater than 1. This is 18 sixths. How about the whole number? Well, 1 pan equals 1. We got 1 pan, 2 pans, 3 pans. So this whole number here would be 3. And this number was, we already said it, 18 sixths. All right. You want to look at those pencils? My Pittsburgh accent is coming out a little bit. Okay. 1 box equals 1 hole. So I could tell the whole number pretty easily. 1 hole? How many holes? 2 holes. So 2 holes. Now we have to figure out the fraction greater than 1. Where'd this 8 come from? Turn and talk to somebody in your house or the floor or your dog or your cat. Where did that 8th come from? Go ahead. I know where that 8th came from. I have 1, 2, 3, 4, 5, 6, 7, 8 pencils in each box. 8 pencils in this box, 8 pencils in this box, because they're the same box. So I know I have 2 holes. I have 8 eighths here. I can either continue counting eighths, or I can do 8 plus 8, or I can use my multiplication knowledge and do 8 times 2 to get how many eighths? Tell somebody. You got it. 16 eighths. So a big, big clue to always remember. Big clue to always remember is when the numerator is bigger than the denominator, the fraction is greater than 1. Say that out loud. When the numerator is bigger than the denominator, the fraction is greater than 1. Okay? So you know here, if you got 16 over 8, it's got to be bigger than 1. If you have 8 over 16, it's not bigger than 1. All right. So let's go into the share and show. I want to try and keep this video to about 10 minutes, and we're getting close. My screen's jumping around on me. Okay. What fraction of the counters are red? Well, my denominator is always the number of counters in the group, or apples, or balloons, or whatever it is that we're talking about. So let's find the denominator. 1, 2, 3, 4, 5, 6, 7, 8. So my denominator is 8. My numerator is the group I want to talk about. Counters are red. 1, 2, 3, 4, 5. So 5 eighths of this group is red. Okay? Let's jump down to number 3 here, because number 2 is very similar to what we just did. Always go back to the directions if you don't know what to do. Write a fraction to name the red part of each group. Well, They want to know about groups here, so I have to count groups. I can't count these individual balloons. I have to count groups. I've got 1 group, 2 groups, 3 groups. I've got a blue group, a red group, and a purple group. So what's my denominator? Tell somebody near you. Remember, your denominator is group. So my denominator here is, you got it, 3. Now, I want the red part of that group. How many of those 3 groups are red? I hope you said 1, because 1 group has 2 red balloons. Now, if we were asking about the fraction of the balloons, we would say 2, but we're talking about fractions of the group. So it's 1 because there's 1 red group. So my fraction here becomes, what do you think? 1 red group out of 3 total groups. So we are 1/3. All right. So you can go in and do these pages in your book if you want for practice, or go on Personal Trainer, because your assignment is going to be to do this on Personal Trainer. My biggest hint for these ones that have a fraction greater than 1, always cover up the extras and just find your denominator in one hole. Then go and find out the numerator. Okay, but finding that denominator is going to be key. Hopefully this makes sense. You should have this page at home. If you have any questions, ask on morning meeting, or we can talk about it there, or on office hours, or even we can set up a separate Zoom call. Okay, guys, I hope this makes sense, and over and out. Bye-bye.